the video for object detection. There is a repo that includes the data set that we're going to be using. So we have cats and dogs, and you can just download this using GitHub Desktop. So open with GitHub Desktop, and you should be able to clone it. I already have it cloned, which is right here. Now we have a couple of data sets. So we do have this original fruit data set, which we're not really working with. Then we have the data set that we're going to use, and we just have a regular cats and dogs data set. So inside of cats and dogs, which is the original one, you will have images by themselves. And inside of the actual data set, you will have two more folders. So the images that are actually there, as well as the labels. So the labels define a boundary box of where that object is actually positioned. And the way we do this is called annotation, and we'll talk about this in a minute. And this describes where the object is. So we can say that from annotation, our object is between maybe this square right here. So this defines the boundary of, let's say, this dog. And you need your data set to be in this kind of format for Yolo, which is our object detection framework. And the script for this week is right here. So this script is a way to run all of this model. We're going to train it using our data. I don't think we need this script because we're not working with the data set. Let me just delete this data set so it's not confusing. So this can also go away. The first step is to install Ultralytics, and then later on we're gonna get the model themselves. So what is Ultralytics? There is a website. If you Google it, you can get it, but it's ultralytics.com. However, you should start with docs.ultralytics.com so you can get to the YOLO part. So Ultralytics is this company that makes these models called YOLO. YOLO stands for You Only Look Once, and these models help you do some form of detection. So you can do classification, but they're really meant for object detection and segmentation. So they have tasks right here. You can see that they do perform classification. There is pose detection and so on and so forth. However, what we're trying to do is detect where the object is and what that object is. So there is a little quick start if you want to quick start this. They have some code that you can run, this pip installation, and then so on and so forth. YOLO models are built with PyTorch. So this is a PyTorch model. It ends up giving a .pt file. So they do have the way you sort of create this model. When you load a model, you load a version of it, and then you specify what the data is using a YAML file, and then you do the training, and then you validate it later on. And then you can export it using PT or ONNX. So this is just a way to train. What I'm gonna do is go to models first and then show you the different models that are available. So there are different versions of YOLO. The one we're using is YOLO V8 because it is very, very stable. It's very, very common. There is a latest one called YOLO 11. It is the latest one. It's new. You can try it out. It works the same way. They do have almost like a list of how you should which one specific version that you want for that version. So if you click on YOLO V8, you can select the exact one that you want. So each one does different things. There is a section for detection, there's a section for segmentation, there's one for poses and key points, there's oriented detection classification. So we already have done classification. This means having a large image and then saying what that image is. So it will only give you one result. Oriented detection and detection are kind of the same thing. With detection, it means it will give you a box or a couple of boxes within the image. It will give you that boundary, and then from that boundary it will find a classification from it. So detection is it being square or rectangle, but in a sort of horizontal or vertical sense. Oriented detection means that box is rotated maybe 45 degrees, maybe 99 degrees. Like it's not really a perfect horizontal or vertical aspect. And then there is instance segmentation. This is when rather than drawing a square, you're drawing a proper boundary. So if you search on Google what segmentation is, it will sort of show you that it is like a boundary of that item. So for example, if you look at these people, you can see that they are sort of highlighted in pink. So that whole line around that person, that's when you segment them. So this is a segmentation of this image. So Yolo can also do that. And pose and key points will be, for example, like for hand gestures and stuff like that. So pose detection, and you'll see things like this. So for example, if you're trying to do a certain pose, you'll see these lines that describe that pose. So Yolo can do all of these, but the one we're doing is detection. So this is the Yolo 8NPT, which is the nano version. This is the smallest version, and they go up in size, and the size makes them bigger and bigger. So the one we're using is Yolo 8VN. And they do describe, depending on the sizes, how much they use or how much they are. In parameters, this is 3.2 million, and it goes all the way to 68 million. And it also describes the speed depending on the GPU size. So we're using this one because it is small, it takes less time, and we're using the Coco dataset, which is the common object dataset. So the common object dataset, if you do click this link, it will tell you that it is the Train 2017 version, and these are all the classes inside of the Coco dataset. So there's a lot of them. There are 100 of them. Sorry, there are 80 of them. Sorry, there are 80 of them. And all of these are available to be classified, to be object detected inside of 8VM. So in our code, we can see that we have imported YOLO V8 BT. And the code is very, very simple. This code is from the site to train. You can find it inside of tasks and detection. And this is the same code. All we do is import the model. They do have 3 ways to import it. You can build one from scratch. You can load a pre-trained version, or you can load a model and then load some weights. So these are different options you want to do. Training is very, very simple. You just declare your data YAML file, how many epochs, and the image size. The image size is default as 640. You can change it if you want, but it is recommended to leave it at 640, especially if you are transfer learning. So we have this. We have the epochs. The image size is 640. The batch size of the image, we're keeping 8 at a time. The project directory is called training. You can change what you want, and this will override this training folder. So what is this data YAML file? This data YAML file is how we load the images. So in our data set, which we can describe as our path, we have a set of folders. We have a train folder and a validation folder, which is our dev folder, just call it validation here. So train, it will take the train and the images, and similarly it will also, if in this the same directory, it will find the label file. So here it will go to train and then labels. It will assume that the labels are close by. So similar to validation, we have valid images. The second thing is you have to declare the names, and these are the numbers that define the actual class name. So 0 defines cat and 1 defines dog. Sometimes these might not be in alphabetical order depending on your label file. So this first number after the line number, this describes the index of the class name. So 0 is cat and 1 is dog. And you need all of these labels to be able to perform detection. I'm gonna close all of these so that there is less going on. Okay, so all we're trying to do is just load a train model. So we're transfer learning, and we're trying to add more of our own images on top. And then we're trying to figure out the results. So let's play this and train it. It is going to run for 20 epochs. Now the second part of this is to actually find the results. So this is going to start training. The training is a little bit messy, but it will finish. It's not a big problem. Let's go back to this part. It gives us a sense of validation. You can validate if you have validation data, But the final part is the prediction. So we want to get the model itself, which we already trained, to detect the result. All you do is take the model and pass it some form of inference data, which is an image, a video, anything you want, and that will give you the result. And then afterwards, you can just show the result right here. So, for example, I could say I have a model and I am gonna go to dataset / test and / images, and I'm just gonna copy the name of this image and I'm gonna paste it there. So that will give me the result. It will also save it. It will probably save it here. And we can also show the result. This code will just give you like a pop-up of the result. So currently this is running. You will see some different keywords here. We have GPU memory. This is how much memory is being used. Currently it's 0. There is things called box loss, class loss, and DFL loss. These are the losses that are penalized on the model so that it can classify the boundary or the classification of the actual object correctly. So these are just losses. If you want to figure out the actual results, like the metrics, you'll have to go to a folder called training, which is the one we described. And in here, you'll have pretty much all of your data, all of the results. There is a results.csv. It is also a little bit messy. You might have to figure out how this runs. You do not have a CSV viewer for VS Code. If you do want it, you can go to extensions and type CSV viewer, and any will work. Let me just install CSV viewer, trust publisher. Okay, let's see if it looks different. Not yet. It's still installing. Okay, let's see. Maybe it looks a little bit better. No. Anyway, you can open this with Excel and it will load correctly. So these are your results. You'll have epoch, the time, the train box loss, train loss, and so on and so forth. And you also have recall, precision, and everything else. So this is the mean average precision at a 50% threshold. This is a new metric. You can research about this, but this just describes how Yolo does its metrics. There are also confusion matrices for this. This is the same thing. We're doing a cat and dog prediction. There is also background. So this is the third thing that you should know about YOLO models, is that they add this background. So if nothing was detected in a sense. So there are images that have cats, but all was predicted was a background. That means there is something wrong that you need to improve with this model. So all of your metrics are inside of here. You can have a look at them. There are graphs as well that describe the model and can help you figure out if your model is overfitting and underfitting. So this is training for object detection. I think it's almost done. This is just to show you what it is. It does say that it has a recall of 0.98 and a precision of 1. Let's see if it works. So going to load this specific model that we just trained, which is just called model. It's just called model. So I'm not going to reload it. I just want to see if it does any better. And I just want to play this. So if I play this, it just shows me this. So if a model, if the picture loads and it doesn't give you a boundary box, it just means that there was no object detected at all. If I was to use the YOLO V8N model and I was to run this, you'll see that it gives you a boundary box. It does classify this as bare, so that's not really correct. Let's try another image. Let me find test, the second image. Let's see this one. If it also thinks that one is a bear. They all look like bears apparently. Let's find some other one. Let's say this one. also think that's a bear. I think this whole there is a very big similarity in dogs and bears. Let's try this one. This definitely looks like a dog. Close these images. Okay. So this one says it's a dog. So it's finally got it correct. So this is just the way you would load a model and get inference from it. So this is object detection. What you're trying to do is um, get this bounding box of this image right here. And then finally you can export this once you're done. Let me, okay, so models. I think we'll just go to guides inside here. For saving a model, let me just search this, saving Yolo model. Okay, exporting with Yolo. So it is export the file. So I'm just gonna go model export. I'm just gonna add a new script and I'm going to type model results dot onxx. So this is a form of exporting. It's not really saving the model. All your models are already resaved as PT files. This is if you want to change the model architecture itself, like a different type of model. So this will export to something else. Once you've trained a model, all your results will still be in the same folder, which is in training, and there's something called weights, and the model which saves automatically is called best.pt. The last.pt is for resuming training. If you, let's say you pause your training, you want to resume, this will be the last weights that you want to use. So this essentially will, I think it has two arguments, format onxx format equals onxx. I don't think it wants a name. Okay, so I think you have to also install this as well. Let's go and pip install this. Pip install onxx. So this is another package if you do want it this way. If you want it that way, if you don't want it, you can always stick with PT files. I will add this over here and install it. And then resave this. Okay, so this will save and give you an ONSX file if you do want it this way, if you want to save it as ONXX. However, if you don't, then just inside of your training, you do have weights. This is the one you will use. Apart from this, it is, I say, a way of getting this data set. And usually when you have your own data set, it is, I would say, without all of these annotations, and you need to find a way to create these bounding boxes. So the original is this cats and dogs. This is, I'd say, an already clean data set. You have already, maybe you have already performed your augmentation. You might have already fully split everything. So you have a ratio going all along. So let's say this is 60%, this is 15%, this is 15%. So you are really ready to train. The only problem is that you do not have the annotations done. And the annotation is a way to make these bounding boxes around your image. So to make these bounding boxes, there is a place called RoboFlow. And RoboFlow is a company that does all of these AI things, and they let you bind all of these, like perform annotation. So bind little boxes on your images, on your videos. And if you go to universe.roboflow.com, you'll be able to perform annotation here. So if you're new, you can create an account. I already have one. I maybe have too many accounts, so it will sign me in. Once you're signed in, it might give you a couple of forms to fill in as you get started. You can fill those in. Then you need to go to project if you're trying to upload your own data. If you don't have your own data, then you can search from all of these different projects. There's so much data on RoboFlow. You can search for almost anything. So if you're doing cancer, um, let's see if this will replay. The server is busy. It does not want to search for cancer. Let's search for something else. Okay, the connection, it says that you stop the connection, wait a few minutes. So let's see if we can do anything else. Maybe the search is not working on RoboFlow at the moment. So let's give it some time, but you can search for as much as you like. Let's just give it some time. Maybe there is a search problem on RoboFlow's website. So I have done this before, so there's a lot of this, but if you have your own images, what you're trying to do is upload those images and perform annotation. So annotation is a very slow process of creating these boxes on the images. So you want to start a new project. I'm going to call this cat and dogs, and I am going to have dogs and cats, and just leave dogs right there. This is private. No, this is public. It's fine. What I'm trying to do is do object detection so I can draw these boxes, and I'm just going to create it. And I can just say no, I don't really want to sync annotation. I'm fine. So once you're here, it will ask you to upload your folder. I have my folder right here. I want to upload this. You can drag and just drop it, or you can select it. Is it empty? No, it does not want to upload anything. So I'll just select the folder. Inside of documents, GitHub, for me it is object detection. I have the cats and dogs folder. You should also have this available if you're just training on this. If you are using your own data set, it's fine. Just upload that. I'm going to click on upload. It will take everything and it will show you that you have 46 unannotated images. So once they're uploaded, you can choose how you want to label them. You can do it yourself, which is the most common way. You can invite people to label together, and you can use AI to label an entire batch of items. I do suggest labeling with a team. If you have people, it does take less time. I only have a couple of images, 48 images to do, so that will not take a lot of time. So I'll just do it myself. However, if you have thousands and thousands of images, it will take you maybe even a week. And if you want to reduce that time, I suggest you do it with someone else. So just ask someone nicely and you may be able to label all of them together. So I'm going to do it by myself. It will create a job for you and it will show you which ones are train images and which ones are test images because you've already grouped them into a folder. So the step is to start annotating, and it will sort of give you a tip on how to build a good model. And the best way is to just select what you need. You don't need the outer boundary of something. If you want a helmet, just select the helmet. You don't have to select someone's head. So if you want the helmet, try and really push the boundary box as close to your object as possible. So it does say create tight bounding boxes. Do not draw images around, don't draw bounding boxes around the whole image. That will not work. Find images that are really, really large and have that object somewhere in the center, somewhere on the side, somewhere you can draw the boundary box, but not as the whole image. So if this is my dog, I will not draw this. This is wrong annotation. And I can just delete this. This is not what I want. All I want is just this much. This is my dog. This is all I need. And it's called dogs EFW. This is not what I want. I just want it to be called dog, for example. So I'm gonna click this one I think it still did not want to. Let me just delete this and do it again. So this is dogs, create class with dog. Okay, so that is my dog. So this will describe this boundary. Once you're done, you go to the next image and then you keep going. This is my cat. So I'm just going to say cat, and then I'm going to create class. So this is the only two classes that I have, cats and dogs. So now all I need to do is just draw these bounding boxes. This is as much as I need. This is a dog. You can use the arrow keys on your keyboard to move between your images really, really quickly. So this is a cat. This is also a cat. This is a dog. This is a dog. So before you start training, you do have to do all of your images. So if you have 1,000 images, you have to annotate all 1,000 images before you start training. So this is a dog. This is a cat. This is a dog. This is a cat. This is a cat. This is a dog. Okay, we're almost halfway. This is a dog. Cat. This is a dog. Okay, we have 15 images left. This is a cat. This is a cat. This is a cat. And this is a cat. This is a cat. And this is also a cat. And this is a cat. This is another cat. This is a dog. This is a dog. This is a dog. Okay, 3 more images. This is a dog. Okay, so now we have this final image. We have 2 more images. This is a cat. And this is a cat. So for example, let's say I made a mistake and I drew this whole thing over here and this was wrong and I had already said cat and I want to remove this. If you want to remove this layer, you go to layers, you select it, and then you just click on delete, and then you can draw the correct bounding box. You can also resize it over here as well. So that is my cat, and that's a cat. So this will be all the classes. I have done all of them, so all I need to do is click this and say add 46 images, and these will be all annotated, and you can see that they have all these bounding boxes. Now you have options. You can just create a new dataset version and then train the model online on RoboFlow. That is one option if you don't want to use your own computer's resources. When you create a new dataset version, what happens is it will let you do some kind of pre-processing and augmentation as well. You can add a pre-processing step, for example, if you want to clean some stuff, turn them into grayscale, resize them, and so on and so forth. Some of these, the ones that have arrows, are not free, so you do have to pay for them. I'm not going to do any pre-processing. I'm fine. With augmentation, you have the same thing. You can add extra augmentation. You can rotate them, crop them, do a lot of different augmentations. These ones are free. You can if you want to. If you don't want to, it's fine. The ones with arrows are not free. You do have to pay for them as well. This will increase the size of your data set. But because you've already bound them with the annotations, that means the annotations will move with you. So it's a good thing if you've already annotated and you just perform augmentation online. It's really, really helpful. I don't want any augmentation. It's fine for me right now. And all I'm going to do is create this data set. And now I have a dataset version, and you can choose to just download the dataset and then train it offline. This is how we got this folder right here that says dataset. So when we download the dataset, we have to select the version of Yolo that we're using. I'm using Yolo v8 and I want to download this to my zip computer. You can select the different versions, other versions that you want. However, we have 8. And if you have performed augmentation with rotations, then you might want to use YOLO V8 with oriented bounding boxes so that those annotations also rotate with you. So YOLO V8, when you continue, it will zip and give you a download file. So this will give you a zip file, and similarly, you'll just get the same thing. You have tests with images, and then you also have the labels of the annotations with the results. So the one describes the dog, and then so on and so forth. So this is how you annotate and how you download the dataset from RoboFlow. If you do choose to train online as well, you can. You can click on this custom train. It will give you options on which model you want to choose, and then you can just train on that, and that will give you a PT file that you can use for deployment later on. So they do have some recommendations as well. There is RFDTR. This is RoboFlow's one of RoboFlow's models. They also have a RoboFlow 3.0, which is YOLO V8 compatible, and there's also YOLO V11. So they stopped using YOLO V8. If you want to use YOLO V11 online, it's fine. It will work. I'm just going to click on RFDTR because this is a lot quicker. Most of them use Coco dataset anyway, so it's fine. I'm going to click on this recommended. I do want a nano. It's fine. I'm not trying to make a big model. And then train from public checkpoint. And that will take all of your data set and then start training it on the RFDTR. So your model is being trained. It will take roughly 15 minutes. They do email you once it's done. 15 minutes is not very, very long. It will finish. They will also show you graphs and like all the metrics that you need for the model. There is also an option for you to evaluate your model by uploading inference data like an image or a video. So for you to try. I will let this train and append another video on top of this so that you can see how you can evaluate a model once it's done training online.